Hello, welcome back. In this segment, I want to talk more about the switch case statements. You have a switch case example here. The switch statement is operating based on the value of x. X is an input, right? We use the user input. If x is 1, we'll execute this portion of the code. When it is 2, we will execute this, but there's no break statement. Therefore, it will come and execute the case 3 until the break statement is hit. Okay. Case 4 is not there. That means we're going to execute the default. Case 5 and 6 share the same code. Okay. So these are the scenarios we have in the switch case example. The question now is, how is this working under the hood? I mean, given an X, how does it know which portion of the actual machine code to run? Okay, how do we analyze that? I have an idea for analyzing it by just rereading this switch case statement using a bunch of go-to statements. Okay, let's look into that. So what I'm going to do is to show you an equivalent version of this, right? Rewritten using go-to. So let me try to show you here. So we have a case 1, 2, 3. 4 is missing. 4 goes to default, right? 5 and 6 share the same code. What about case 0? Case 0 should also go to default. Okay. So what I have here is a table of pointers, right? I'll show you what it means loc def in a moment. Location def default is the default code, right? The default code says w equal to 2, and then done means return. You can see here, return w is the done part. Okay. So I mean, we can rewrite this as a multi-way branch statement, right? Anything more than 6, right, should be going to default. That's the reason why we are going to default. Okay. Default is w equal to 2, done. Anything negative is interesting. Let's say my x is -1. In that case, we should also go to default. How are we handling the negative case? We do a small trick. We convert the switch case variable x to unsigned type. Okay. So if x is a negative number, unsigned means it's a very large number. Therefore, it will be greater than 6. And therefore, it will go to the default location. So we already talked about converting signed types into unsigned or vice versa. So you may need to recall that. Essentially, that's how we handle the negative case. For negative case, we go to the default. And anything else is straightforward. We just go into the jump table here, bunch of pointers, right? And then we jump into that particular location. Let's say the case, to be simple, index is 1, meaning x is 1. So in the case of x is equal to 1, indexes will be 1. So we go to one location. Let's see what is there in one location, right? Y times z, and then done. Case 2 runs y by z, and then falls through the case 3. Case 5 and 6 share the same code, which we can see here. I put case 5, and in the jump table, I put 5 2 times. Okay. That means case 5 and 6 share the same code when the index is either 5 or 6. Right? Case 4 is not there, which means we need to go to the default. That's why I put case 4 to be default. Case 0 is not there. That's the default. Okay. Anything above 6 automatically is handled here. We don't put it into the jump table. Otherwise, it will be enormous. So anything more than 6, we go to the default. Anything negative is automatically taken care of because negative number will be huge when we convert it into unsigned. So that will be taken care here. Okay, that's all. This is how you can visualize a switch case statement as just a multi-way branch statement. You just have a bunch of pointers, right? This table has a bunch of pointers. These are all pointers pointing to different locations of the code we would like to run, right? And the code fragments are organized in such a way that, if 2 case statements share the same code, we put the same pointer value. For example, 5 and 6, same value. And if there's a fall through, we organize the code in such a way that, for example, case 2 executes and then case 3 executes, right? Because case 2 has no break statement. In that case, we put like this, case 2, and there's no go to done, case 3 is there. Okay. So this is basically how you could rewrite your switch case statement into a multi-way branch statement. Okay. So, all right, let's look at how the assembly code looks like for this example, right? Let's look at this now. Let's GCC disassemble our main. Main calls the switch example. Now we can see something interesting. There's a lot of assembly code, but I will show you the most important ones, right? Okay, there is a notion called jump table here. Okay, here it is. So this particular table, right? If you look at this address, you will see lots of pointers hiding there. Okay. So something very quickly. Remember, as I said on the source code, anything more than 6, we directly go to the default. This is where it's happening. Anything more than 6, we go into the default, which is 8048.423. Okay, let's see where it is. Here it is. We moved W equal to 2. Okay, that's essentially what's happening here. This is our W local variable, and 2 is moved. Okay, let's look at the address and investigate what are the things inside there. Okay, let's just look at 7 words, for example. What you're seeing here is a bunch of addresses. Remember, case 0 is not there explicitly in the code, therefore it's pointing to the default. This is the default. So this is case 0, this is case 1, this is case 2, this is case 3. Case 4 is default. Case 4 is default. Okay. Case 5 and the 6 share the same code. That's the reason you have it here. Okay. And fall through cannot be seen directly from the jump table. You need to disassemble each of these address, right? And then see whether, for example, in our code, we saw case 2 falls through to case 3, right? Case 2 is this. Case 3 is this. We can disassemble, let's say, 08048.409. This is case 2. Okay. Let me make it more precise. This is, let's look at case 2, 5 instructions, right? Okay. And the case 3, this is 0, 1, 2, and 3. Okay, let's do case 3. Another 5 instructions. Okay, we can see whether there is any overlap in the code, right? Here you can see case 5 starts at instruction 8048.413. Yeah, here it is. Move, blah, blah. But if you look at case 2, case 2 has 8409, but there is no jump statement. It's just continuously executing. That means there is overlap between those 2 case statements. And you can see there is overlap here naturally. Okay, so we can find out the cases that are overlapping, meaning fall through cases. We can also find the cases that are sharing the same code base. We saw case 5 and 6 sharing the same code base by looking at the jump table. Like we can see here, this is case 0, 1, 2, 3, 4, 5. This is 5 and this is 6. They both have the same address, okay, code address. That's because they share the same code. So this switch case statement is simple as finding where the jump table is and then map it to different code segments. That's how you could reverse engineer the actual switch case statements just from the binary. Okay, that's all. Thank you very much.